Welcome back, guys. So in the last tutorial we learned about some basic simple OD operations for the ST20, and in this video we're going to learn about some more advanced OD operations or special considerations you need to make while you're working with complex OD geometry. So first of all, for all the for all the simple stuff I'm gonna go pretty quick, but this is the part we are going to focus on and we'll get straight into it. So let's switch to manufacture. We've already worked with the first setup, but now we're going to turn our attention to the second setup. Just like the first setup, we're going to start off with a simple facing. So all I'll do is go to turning, activate my new setup, and go for a single face. I am going to select tools from the previous setup. Actually no, in this case, just for illustration purpose, I'm going to define this material to be P0. So ISO grade P0, that's where most of the mild steels will fit in. Excuse me. And we'll see how we'll have to make selections accordingly. So I'll go to ST20, and this time around I'm going to go for turning general because we learned that turning general is an appropriate tool. Excuse me. So last time we used a C-style insert. Now I have a deep cavity here, and I can see myself using a V-style insert more predominantly in this cam. So I'm going to instead use a V-style insert this time. So I'm going to go ahead and filter for V-style. Now again, I have a whole bunch of options. This one's not going to work because it has no P0. This one's also not going to work. This one can. This one can. This one also can't work. And these are just left-handed equivalents of the right-handed ones. And we're going to need a right-handed tool to begin with. You will see the applications of left-handed tools in this tutorial. So the two options I have is KCM25B and KCP25B. Now both of them are valid, and I'm just going to pick one. So let's go with KCP25B, right-handed V-style insert, and we're going to go for P0, and I'm going to hit select. Now just like before, I'm going to enable multiple passes. I'm going to set this to tool underscore corner radius times 0.9. I'm going to go to radii, and I'm going to give myself some breathing room in the outer radius. I'm going to go to passes, uncheck same, make this 90 degrees, and with that my facing operation should be done. So let's have a look, simulate, and the behavior is as expected. Again, just for illustration purpose, if you see closely, the cut is no deeper than the corner radius. So that's exactly what our goal was, and we have achieved said goal. And that's good. So facing's done. The next thing I'm going to do, just like last time, is I'm going to go for a turning roughing strategy. And I'm going to go with the same tool. Geometry starts there. On the endpoint, I'm going to give a tangential extension of 0.25. This should already be set to tool underscore depth of cut. Now for stock to leave, I'm going to leave 0 in Z, and in X I'm going to leave tool underscore depth of cut. Now just like before, here again my finishing tool happens to be the same as my roughing tool, so I'm simply able to use the same depth of cut. However, if my finishing tool were different, my depth of cut that I leave for X stock to leave has to be the depth of cut of the tool used for subsequent finishing. In this case it happens to be the same tool. If in your case it happens to be a different tool, you need to use the depth of cut value for the finishing tool. Going back to passes, I'm going to click OK, and this looks good. Now it has some behavior that I don't like. So the first behavior that I don't like is it's trying to get into this groove, and I don't want it to get into this groove because I will be using a grooving tool to achieve this. I do want it to get into this groove. So let's see if I have any ability to selectively control that. Let's go to geometry. Groove suppression, interesting. Okay, so there is a built-in feature, and I'm going to try to select a surface. And right now my stock model is getting in the way. So I'm going to try to suppress this groove, and let's see if it can ignore it. And it doesn't look like it's ignoring it. To be honest, this is the first time I'm looking at this feature. So I'm going to try to say suppress machining of one or more grooves. It enables you to specify one or more grooves to suppress when machining. To specify the groove, select the faces contained by the grooves. This option requires turning on the spun profile option in the setup dialog box. So I'm just going to try again, but this time selecting all the faces. So this one, and this one, and click OK. And I'm successfully able to suppress the groove, and I can just quickly check setup and make sure spun profile is enabled. So first time using the feature, the approach you should really go for is reading through and trying to find if there is something. I'm sorry, I'm going to repeat that. The approach you really should go for is, if you don't understand a feature in CAM operation, hover over it, see the description. If you still don't understand it, Google search it. Failing that, try to seek help of a peer mentor at the center. So I'm just going to look at the simulation carefully. And there we go. I'm going to make my stock transparent so I can see. Okay, I'm happy with this behavior. Now I'm a little concerned with this behavior. So if I slow this down, okay, I don't like that. If you guys see that, I do not like the tool making contact like that. So let's see if there's anything we can do to avoid it from doing that. Let's go to passes, horizontal, make sharp corners. I don't think, no dragging. Use spec. What about cycles? Horizontal, back passes, directions front to back, geometry, tangential extensions, tool limit. Clearance. This angled entry. Okay, let's see if angled entry does something. Okay, I'm getting a bunch of warnings. Entry angle has been modified to avoid gouge. So I don't think angled entry is what we need. But I'm really trying to see if there's some way of us avoiding cutting that area specifically. Some sort of tool clearance. This adjusts the face center line. Okay, now geometry, groove suppression is already used. Contact point, tool limits. Passes, vertical back and forth both ways, maximum depth of cut, even depth of cuts, make sharp corners. For sharp This creates toolpath that avoids sudden change in direction. A sharp intersection using can gouge the part. No dragging. Maybe no dragging might work. Let's see. Simulate. No, it's still dragging. Okay, exit simulation. Let me try to read up on no dragging and see if I can use that to control passes. No dragging. When selected, moves that apply negative pressure on the insert are eliminated. Remove cuts up vertical faces before reaching. Cut down the wall from the outside. No dragging limit. Between the part and the face at the cutting that triggers no drag tool action. The end of the face. Even a 5-degree clearance would do, but it seems to have absolutely no effects. So unfortunately I won't be able to isolate this region easily. Okay, so unfortunately that is something that I'll just have to accept, and that's not exactly good, but unfortunately there's nothing I don't see anything we can do about that. I'm just going to simulate it again and see how much of a problem this is going to be. So this is a high risk area where when the tool plunges in, there's a high chance that the tool would break, and I would have to look at this very carefully while I'm running the part to make sure that doesn't happen. Now this can be followed by a finishing pass, and one quick trick is to use a derived operation which basically copies a lot of the properties, and this should be as simple as clicking OK, and looks like that did the job. Simulate. Okay, I saw a collision. Rapid collision with stock. I don't really see that actually being a collision, but I do see a warning, and the warning says lead out was modified. So this is similar to something we faced earlier. We're going to change the lead out to 90 and click OK, and we no longer have that problem. So go ahead and we're good. Okay, now the next thing we need to do is get to this region. Now if you look at the stock to leave, the stock to leave here is quite minimal. So there isn't much stock to leave here. I mean, what I'm trying to say is the excess material here is not that big. So it is completely fine for me to not do another roughing and just go straight for a finishing pass. However, if you had more material here, you might want to do a roughing strategy to target that. So in our case, we're going to go straight for a finishing strategy. So I'm going to start with turning profile finish, and now I'm going to select a different tool. So what do I have here? I have KCP25B right hand V insert. I'm going to go to ST20, filter for turning general, filter for type V, and I'm gonna go for KCP25B, but this time I'm going to go for a left-handed tool. and that is what the left-handed tool looks like. Now, it's very important that I only use the left-handed tool in the affected region. So the first thing I'm going to do is I am going to explicitly define selections. So it starts here and it ends here. That's the only region I care about. All of these other values should be fine, and instead of coming from front to back, now it's going to go from back to front, and everything else should be fine. Now if you have a look, simulate, and it's very important that you check this because this is going to get really close to the chuck, and you guys can see that it's getting pretty close. Okay, now the other thing it's trying to do is it's trying to take off a cut here. So one thing I can do that might help is in the geometry tab I can enable something called rest machining. Now rest machining is the idea that it only tries to machine the area that has excess stock, and it's using the previous operation as an indicator of what area to machine. Now as you see with that modification, now it's only targeting this area and not trying to jump into the other area that we previously saw it jump into. Simulate. There we go. And we have a finished part. So there is our cut. Exit simulation, and that finishes up that area. Now the next thing is to make this groove. Now to make this groove, what's going to be helpful is if I'm able to get our grooving tool to fit in here. Now whether our grooving tool is going to fit in here depends on the size of the groove. So let's look at what size the groove is. So if I go back into the design environment and I inspect this side to this side, I know this is a 0.1 groove. Come back to manufacturing and go to our tool libraries. One thing that we had were we can filter all our grooving tools in the ST20. So I'm going to go for turning, turn grooving, and let's look at all the sizes that we have. So it shows the corner radius here. I might want a couple different parameters, tool length, diameter. Let's see if there's something called groove width. Yes. And that value is right there. I don't seem to be able to rearrange it. Okay, so the one that we used for cutoff previously has a value of 0.157. Unfortunately, we already checked and this one has a value of 0.1. So that grooving tool is too big to fit in there. So we can't use that one. Let's see what other options we have. ST20, turning, grooving, and looking at the groove width. The other one, the round insert, is 1/4 inch, so that's also too big. But these other ones should function. So we have a 0.062 and you want to go for the biggest grooving tool you have. And we go here. And one thing we have to notice is this is really small. Now if I go down, it says do not exceed 0.043. What it's trying to tell us here is the width of our groove is going to be at least 0.062. You can definitely do bigger grooves by taking the grooving tool multiple times, and 0.062 fits our criteria, but the maximum depth that you're allowed is 0.043. Now just by looking at that number, I know this groove width is too deep. Now if I look, inspect from here to here, and I don't think it is going to give me a distance easily, but I'm going to go back in design and try to see one of the sketches. Edit sketch right here. So this has a depth of 0.2, so that is on a completely different order of magnitude. Now unfortunately we can't work with that, so we have two choices here, actually three, and you will run into this all the time. Certain features are just not manufacturable. So we can either decrease the depth of this to something like 0.04 and use that small grooving tool multiple times to get a groove, or we can increase the width to 0.125, which is the size of our cutoff tool. I think it's 0.125, I would have to double check, and accept the fact that our groove is going to be wider. So choice 1, decrease the depth of the groove. Choice 2, increase the width of the groove. Choice number 3, and if you really need this exact groove, as a student you do have the ability to purchase specialized tools that can do the job that you're trying to do. Unfortunately, there isn't a solution that we have on hand. So I'm going to go for the easier route and increase the groove width. But before I do that, I just want to make sure that I find out what the size of my tool is. So if I go to library, and in simple we used it, it's 0.157. So I'm going to set the size to 0.157. Go here, edit sketch, make sure I home it, 0.157. That makes the groove wider, and as a result of this wider groove, now I should be able to use the tool. So I will come in here and I'm going to go for single groove. Now I want to warn you against turning grooving. Turning grooving has a lot of issues, and even if you are using a smaller grooving tool to make a wider groove, use multiple simple grooves. Turning groove can be used to do all of those multiple operations in just one operation, but you need a lot of experience with turning grooving to make it actually work correctly. If you use it and you don't have that experience, there is potential for you to break an insert. So stick to turning simple groove. I click that, I select my cutoff, I make sure I have P0 selected, and I have to give it a groove position. So I'm going to give it this, and right now it is locating my groove in the wrong location. So I'm going to say alignment back, and that makes it align correctly in the center of the groove. Make sure this doesn't go any deeper. Check other parameters. Okay, now here's an important parameter. You want your grooving tool to spend a little bit of time in the bottom so a full rotation happens before you pull out. If you don't do that, you'll start the cut and start pulling out, and you'll get an uneven circle. So I'm going to give it a very small amount of time down there, and I'm going to give it 0.01 second, or maybe even 0.1 second, and that should be sufficient to get that groove. Click OK, and I'm just going to regenerate the other toolpaths because we made a couple changes. And now I'm going to have a look. Simulate. So we have our facing, we have our roughing, we have that problem area that I don't like, and then we have a back to front, and then we have a groove there. And the next thing we're going to do is part it off. So I'm just going to go for a simple part off. Or I'll try to show you something. You are able to use operations from other areas. So I'm going to copy this one and I'm going to paste it here. And make sure that it's changed to P0. Disable the edge braking, and I'm going to keep this outer radius be the stock OD and click OK. Let me make sure I did not accidentally create a duplicate of tools. Nope, I'm just using 3 tools, and I'll just watch the simulation again. Simulate. Our facing seems to be working fine. A problem area that we just can't avoid. We are clearing here. We make one groove and then we come back and make a deeper groove, and the part is parted off. Now, just like before, you can make modifications to reduce your need to do cleanup. So let's see some modifications that we can make. So the first one would be, I need to activate this and isolate. So the first modification could be, I might want rounded edges all over here. So I might want a fillet. Let's go with the fillet. Here, 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 and here. And it's going to be really small, 0.01. There we go. So we slightly rounded those out. Let's have a look. A small round. Click OK. And I might choose to do chamfers on the other side. So I want a chamfer here, here, and here, 0.01. And I chamfered those out. So I got a couple of fillets here. And then I got a couple of chamfers here. I go back to my manufacture, and now I need to make a couple of edits to make sure everything works. So I'm going to regenerate everything. Okay, so facing looks good still. It's still cleaning up the surface. Profile roughing. Profile roughing still looks good, but once again, it's trying to get into that groove. So I might have to make a couple modifications here. I'm okay with it taking a small nosedive here, and that is acceptable to me. But I don't like it taking this big gouge down here. So I'll have to do something similar to what we did before. I'm going to have to explicitly define the back, which is going to be right here. And I'll be doing a tangential extension from there. Click OK. And as a result, now it goes straight. Probably the same thing for finishing. Explicitly define the back. Selection. Take this edge. Click OK. Same thing there. And then profile finishing. I think it lost some of the references that it was relying on. So I'm going to have to select the front and back manually again. And I'm going to select this as the front and this as the back. And click OK. And that should be good too. Next, I'm going to look at, this should be fine. And in part of, I'm going to remodify this to be model OD. In geometry, I'm going to enable edge break, and I'm going to give it a chamfer of 1/10 thou, and click OK. And now let's see the part in simulation as our final sanity check. So facing looks fine. OD roughing looks fine too. And then we come for finishing. And then finish from there. make a groove there, and then make a chamfer, and we're done with the part off. And there we go, there we have our resultant part. And that is going to be it for this tutorial. The key takeaway I want you guys to have is, especially with these areas, you need to be considerate about how you approach them. You should use a combination of I'm sorry, you should use a combination of left and right-handed tools, so each tool is doing what it's good at, and you should try and avoid the dragging scenario that we had with our right-handed tool as much as possible. Unfortunately here it doesn't seem like we can do anything, but you should try and avoid that as much as possible. That's it for this tutorial. In the next one we are going to learn about basic moderate ID work, so we're going to learn the basics as well, a little bit of the advanced stuff. I'll see you guys on the next one.